conversation has to proceed. So in Lex, we can define the intent. We can also integrate the voice-based systems. We can design the entire flow of the entire conversation, and then that conversation can be plugged into our Lambda services. And then once we are done, then we can deploy this on the website, or we can integrate that with our own website, right? So for example, the users will be texting order flowers, and this will be processed, and then this request will be coming down to the Amazon EC2 server, and then this request will be passed on to Lex, and then this is going to be processed by Lambda. Lambda is a part of NoSQL, or not NoSQL, serverless computing platform through which we can process the request. So instead of deploying the entire server, we can use it as a part of handling the serverless request, and then it can be monitored using CloudWatch, and when the request has been processed, it can be sent back to Lex, and it can be returned to the end user. And in here, the entire architecture, we'll be using AWS Lambda. Audio and video is fine for everyone. In case you're having any kind of trouble in the audio and video part, so you can try rejoining the webinar, or you can try changing the network. That will solve the issue from your side. So now let's first of all start our journey with understanding what exactly is a chatbot. So chatbot, as we know, is a computer program which conducts a conversation in natural language via speech or a text, like we have been discussing on the websites. So when we are trying to converse with any support team or any support system, then it understands. Suppose if we as a human user, if we type in okay order flowers, then it will understand okay what exactly that the consumer is trying to say here, right? It will automatically know what exactly is the intent of the user, and how the same has to be processed back, and then the results should be sent back to the user, right? So and that exactly is what and we know that the first chatbot was created back in 1966 to mimic human conversation. And the chatbot applications, again, it is applicable to almost every vertical on online shopping, booking tickets, news reports, order food. So they are almost applicable in almost every vertical that we can think of. They are applicable in almost every vertical that we can think of. And again, chatbot types are they are command bots, they are self-learning bots. That means again, in the command bots is they have a specific set of commands. They have a specific set of commands, and they start interpreting accordingly. Or if we want them to learn on their own, so based on however the users are given the command, we want them to learn on their own, then that is something that we can achieve by using the concepts of self-learning. So here we can apply deep learning and machine learning modules, and the system can keep on improvising on its own to increase their entire response time. So that the next time we don't have to train the system would have been trained on its own. That exactly is what we try to achieve by using the self-learning bots. This consists of multiple services. AWS consists of 150 plus services from different categories. For example, we have predefined services for computation, for storage, for networking, for different parameters, right? For IoT, for AR/VR, for artificial intelligence, right? For databases. So there are multiple scenarios. There are multiple services available, and Lex is a service available inside the artificial intelligence system, where we can use Amazon Lex to build conversational interfaces that we can easily integrate into any application using voice and text. And when we say conversational interface, that means we have to make sure that we are building a system which can easily interpret what exactly is being given as the input to the system. Now, input can be in both formats. Input can be input can be in the voice, or input can be in the text format as well. Input can be in both, right? So when we say voice format, now we know that we have our assistants, like we have Alexa, we have Siri, right? So here we can use this entire system to simply automate the task, correct? Or we can use the text part as well to type in the command, and then it will behave accordingly. So there are multiple ways through which we can give the commands to the system, and then it will process it, and then it will give the desired result output accordingly. And when we talk about processing the input given by the user, we have to use something called as natural language processing, called as NLP. So natural language processing is, we know that in English we have the same words which mean different things. We have same words which mean different things here, right? Because again, same words, when we say same words means different thing, that means when they are used in different contexts, they mean completely different things here. Okay, so where we used in differently, then they mean simply different things. For example, let's suppose we have a date. For example, let me showcase you what exactly we are talking about. For example, let's say if we open up these kind of sentences, like we have this one. Now when we talk about date here, right? So now when we talk about crane, when we use the bird is a crane, that means we are talking about a bird type, right? Then again, when we use the crane in a sentence, she had to crane her neck to see the movie, that means we are talking about a physical movement. And if we talk about in this scenario, they had to use a crane to lift the object. Then we don't mean that we had to use a bird. We don't mean that we had to use a bird in order to lift the object, right? That's why here we have to make sure. That's why here we have to make sure we are learning these exactly as per a we are the system understands in which context the entire response is given, right? So for example, suppose if we ask the system, okay, show me images of a crane, right, of the bird crane. Then again, if the system shows us the image of an actual crane used for lifting the object, then that will be an incorrect response. So we have to make sure that the user system understands in which context we are giving the command, so that they can process it and then they can give the desired results accordingly, right? Same way for the same way like we have date. Now date is an actual date, or date can be going out, or it can simply mean going out together, right? Same way we have leaves. The children love to play in the leaves. That is actual leaves, right? And then they do not like when their father leaves the work. So these words, they mean different things. And a system, it needs to understand in which context we are giving the command. And a simple example is Google and all the search engines. Why you think has Google sustained for 2 decades? Because of the accuracy in which the results are being generated. So Google exactly knows what exactly we are looking for as per the query that we have entered, and that exactly is the reason for their success for last 2 decades now, right? Natural language processing is based on the command as well. That means what kind of command we are trying to give here, right? Based on the textual format. And same way, if we have to speak up. For example, let's say we use Google Assistant, we use Alexa, we use Siri, right? So if we are using these kind of voice-based system, we have to make them understand what exactly we are trying to speak. We have to make them understand our different dialects, how the words are pronounced, which particular voice-based system means what, right? Because again, we know that even in English or in any language, there are multiple dialects, right? There can be multiple variations in which each and every word they are pronounced. So we have to train the system with thousands and petabytes of data so that now system understands, okay, a single word, how is that, what are different ways in which they can be pronounced and what exactly it means so that it can behave accordingly, right? A simple are the different components of Amazon Lex. First of all, we have Amazon bot. So Amazon bot is simply an artificial intelligence program that simulates the interactive conversation. That simulates the interactive conversation. That exactly is what Lex is all about. And that means now at the end, we have to create a bot, right? At the end, we do have to create a bot so that it can try to interpret whatever we are trying to speak here, right? That's the well, suppose we want that. And to understand how exactly Amazon Lex operates, so first of all, we have to create a chatbot and configure it within the intent, slots, and utterances. Then we have to test the bot on the text window slide provided by the Lex console. Then we can publish a version and then we can say, yes, Priti, we can say for small computation and for the computation, it's a for small computation requirement. If we have the requirement of computation for a small purpose or only for a small period